Let's look at this geometric problem. Point E is the midpoint of side CD in square ABCD, and BE meets diagonal AC at point F. Point F. The area of quadrilateral AFED, that's this, is 45. What is the area of ABCD? By reading this problem, you probably know that we have very good understanding of point A, B, C, D, because they are just the vertices of square ABCD, right? And then we also know E pretty well, because it bisects CD, right? It bisects CD. And the only point that's unclear is this point, F. So I think there may be quite a few ways to solve this problem, but most of them cannot get away without a good understanding of this point F. This point F. And in this video, I will use a method to apply the knowledge of similar triangles to solve this problem. This may not be the smartest way or the fastest way to solve this problem, but I think this method reveals the very basics of the ideas hidden behind all the numbers and figures. Alright, let's get started. As to this problem, since we know the area of AFED, right? And this is a very irregular shape. In order to find the relationships between this area and the area of ABCD, we want to cut this quadrilateral into smaller parts so that the area of each smaller part is easier to calculate, or is easier to be expressed by some characteristics of the square ABCD. Okay, so now let's first set the side of ABCD equals A. So AB equals A. And then let's connect DF. So this is the way that we cut AFED. And then the areas of these two smaller triangles can be easily expressed in terms of A, the side of ABCD. Okay, so before we do that, as I mentioned earlier, that we need some good understanding of this point F, which means that we want to know how this F cut the diagonal AC, or how it cuts the line BE. That's basically the same thing. Why? Because let's look at these two triangles. The triangle FAB and the triangle FCE. Obviously, these two angles are equal, right? And because ABCD is a square, so AB is parallel to CD. Therefore, this angle equals this angle. Then immediately we get triangle FAB is similar to triangle FCE. And we are not done yet, because at the same time we know that the side AB corresponds to the side CE. And the CE is half of A. AB is A. So that's A over a half of A. And that equals 2. So this 2 is very interesting. It's not only the ratio of sides AB and CE, it's also the ratio of the two similar triangles FAB and FCE, which means that all corresponding line segments in these two triangles have the same ratio 2. Good. This is very important, and we will use this property repeatedly in the following calculation. Now let's come back to the two smaller triangles that we created. The triangle FDE and we want to express the area of this triangle in terms of A, then what is it? Okay, so the area of this triangle equals a half times the base. So which side should we choose as base? The easiest choice would be DE, right? Because that is half A. We know the length already. Then how about the height? Let's draw a perpendicular line from F to DC, right? Therefore, the distance of this line segment, this perpendicular line segment, is H. That is our height. But the point is, what is H? Alright, let's do the same thing. Let's draw this height in this triangle FBA or FAB, right? Let's draw this height. Let's call that H2. And don't forget, these two similar triangles have a ratio of 2. Therefore, their corresponding height has the ratio of 2 as well. So H2 over H1 equals 2. And this is H1. Let's call this H1. At the same time, we know that H1 plus H2 shall equal BC and equals A. So with these two equations, it'll be quite straightforward to see that H2 equals 2/3 of A and H1 equals 1/3 of A. Therefore, let's continue this calculation. So this equals a half times a half of A times a third of A, and it equals 1/12 of A squared. Now let's look at this triangle, triangle FAD. Alright, let's calculate the area of triangle FAD. And again, it equals a half times the base. Let's use AD. That's the easiest choice, right? Because we know the length is A already. And times the height. Let's call this height H. So we'll draw this H from F to the line AD, right? This is the right angle. Now let's call this length is H3. The question is, what is H3? So let's come back to this ratio again. As I said, we'll use this ratio repeatedly. So with this ratio, we would know that AF divided by CF equals 2. And that implies AF over AF plus CF, right, equals 2/3. And that actually equals AF over AC. Now let's look at these two triangles. Right triangle AFG. So let's call this point G. That's where the perpendicular line FG meets AD. Okay, this right triangle and the right triangle ACD. So obviously these two right triangles are similar. And this is because they share the same angle, this DAC. And both are right triangles. Therefore, the two triangles are similar. And what's the ratio of these two triangles? That's 2/3, right? This number. 2/3, which is the ratio of AF to AC. Therefore, we combine these two pieces of information, we get H3 equals 2/3 of DC, which is 2/3 of A. Good. Now let's come back to this area of triangle FAD. So this equals 1/2 times A times 2/3 of A. And this equals, we cancel the 2. So that's 1/3 of A squared. Now, when we add up the area of these two triangles, we'll get the triangle AFED equals 1/12 of a squared plus 1/3 of a squared, and that equals the denominator is 12 and the top is 1 plus 4 of a squared. That's 5/12 of a squared. And don't forget, this equals 45. It's here. The area of the quadrilateral AFED is 45. So we solve this equation. A squared equals 45 times 12/5. We cancel this 5, we get 9 here. That equals 108. Therefore, the answer is B. B is our choice. So basically what we did here is to use similar triangles and the properties or the ratios of similar triangles to find the basic properties of this point F, which is the most important point within this problem. And the derivations in this video may not be mathematically rigorous. For example, this idea, h1 plus h2 equals a. So in order to know that, we have to prove that these 3 points, let's call that M, these 3 points, M, F, N, has to be on one line. And we didn't prove that. It's not hard to prove, but we just skipped that part, because for this multiple choice problem, that's not necessary. In such exams, if you want to get the correct answer within a very reasonable amount of time, sometimes you have to skip some steps, and maybe you can even use some intuitions. If you want to complete a very rigorous mathematical proof, that may take you a while beyond, let's say, 10 minutes or more. Alright, that's so much for this problem. If you like this video, please subscribe the channel and thumb up. If you have questions, please comment.